All right, these problems are going to help you succeed on the test that we began on Friday and we will conclude on Monday. I'm going to do if you have not already, you can find these problems on the calendar. I'm going to work the odd numbered problems. I'll leave the even numbered problems for you. I've selected problems very similar to the ones on the test. And as you can see, the odd numbered problem here is similar to the adjacent even numbered problem. Okay, so in general, if there's a parentheses, the first thing we will do is distribute. That is, the constant term outside the parentheses, we will multiply by both terms inside. 4 times both 2x and minus 5. So this yields 12 plus 4 times 2x is 8x. 4 times minus 5 is minus 20. If the term outside, the operation outside is addition, these two terms will remain the same sign. Next, we look to combine like terms. In this case, the two like terms are constants, 12 and minus 20. 12 minus 20 is a negative 8. 8x remains the same. Minus 8 equals 20. I believe we're probably all proficient from this point out, but we'll continue. Our goal is to get x by itself. Currently, x is being multiplied by 8, the coefficient, and then 8 is being subtracted. Well, we will undo the subtract 8 first. The inverse of subtraction is addition, adding 8 to both sides. Negative 8 and positive 8 add to 0, leaving only 8x on the left. 20 plus 8 is 28 on the right. Lastly, we will divide by the coefficient 8. Eight divides 8 to leave 1x. We simply write that as x. And 28 divides by 8. We will use our calculator to assist with this operation. Let's hope that I'm able to show this. 28 divide by 8. Enter. Yields 7 over 2. And it will be best in this context to leave it as this improper fraction. We could hit Control and Enter and use the terminating decimal 3.5. Either of those will be satisfactory. If it's a decimal that doesn't terminate, the calculator will show it as a terminating decimal. But if it's a little longer decimal, then the improper fraction will be better. In general, leaving as the improper fraction will be the way we conduct our business. So, x is 7 over 2. Our last step is to take the 7 over 2 and substitute it back into the original to verify. I'll do the substitution in red. 12 remains the same, plus 4 remains the same, open parentheses. 2, x we believe to be 7 over 2. I have a nested parenthesis. I could simply use times. When I show substitution, I will generally use a parenthesis. Subtract 5, close parenthesis. I'm hoping that this is 20. All right. I will use the calculator to evaluate the left expression. 12 plus 4, open parentheses, 2, second open parentheses, 7 divide 2, close, minus 5, close. And hopefully this will be 20. And it is. So, this statement is true. So that allows us to conclude that x equal 7 over 2 is a solution. Now you give number 2 a try. It's virtually identical to number 1. Okay. Moving on to number 3. Again, we see we have a parentheses and a term outside. So we'll be employing the distributive property. The left side remains 40 equals 5c remains the same. In this case, it is a subtraction outside the parentheses with the term connected. We can consider this a negative 3. It is the same as saying plus a negative 3. So in this case, negative 3 times 5 becomes minus 15. Negative 3 times negative 7 becomes a plus 21c. When multiplying by negative, we see both of these terms change signs. The minus became a plus, and this positive here became a subtract. Okay, we look to combine like terms on the right-hand side, the like terms being 5c plus 21c. 5c plus 21c is 26c. 40 remains the same. 26c minus 15. Solving for c. Notice this time the variable's on the right-hand side. We could rewrite this as 26c minus 15 equals 40, but there's no need to do that. I simply want to get c by itself. I will first use the inverse to eliminate this minus 15, adding 15 to both sides of the equal sign. 15 cancels with 15 to leave 26c on the right-hand side. 40 plus 15 is 55. Dividing by the coefficient 26 on both sides. 26 divides by 26 to leave c. 55 divided by 26, those appear to be relatively prime, but I will use my calculator to verify. 55 divide 26. If the calculator returns that same fraction, that indicates to you that that is the most reduced fraction. So our best answer here is 55 over 26. We could find a decimal, but that decimal will be much harder to use than 55 divided 26. Now I'm going to verify that solution. This time I will come over to the right-hand side. The original statement is 40 equals 5c minus 3 times this quantity. So 40 equals 5. Instead of c, we substitute 55 divide 26. Close. Minus 3. Open. 5 minus 7. Again, 55 over 26. And we need a double close. 1 for c and 1 for the parentheses. Again, where there was c, I have inserted the parentheses in 55 over 26. And this closed parentheses here is this one. All right, using the calculator, I will evaluate this expression. Five, open, 55 divide 26, close, minus 3, open, 5 minus 7, open again, 55 divide 26, close, close. We're hoping that this is 40. And it is. So, this statement is true. Thus, 55 divide 26 equals C is a solution. You now try number 4. Last problem. In this case, we have v divided 4 plus 7 is equal to 12. Well, the goal is to get v by itself, so again, I will go after the term that's added or subtracted first. It's a plus 7. We use the inverse, subtract 7 on both sides of the equation. 7 subtract 7, leaving v over 4 in the left expression. 12 minus 7 is 5. Most of the time, our final step is to divide by the coefficient because we have a multiply. But in this case, it's v divide 4. The inverse of division is multiplication. I will indicate multiplication by connecting. Connected means multiplied in algebra. Multiplying by 4 on the left side, multiplying by 4 on the right side. 4 divides 4 to leave 1v. Don't have to write the 1. 5 times 4 is 20. Again, we will substitute 20 in place of v. 20 divide 4 plus 7. Is that equal to 12? Divide by 4 plus 7. Indeed, that is 12. 20 divided by 4 is 5. 5 plus 7 is 12. This statement is true. Since this statement is true, I can say v equal 20 is a solution. All right, you try problem number 6. If you're able to solve these problems, you should be in good shape completing your test on Monday.